Okay. So today, December 1st, and last week of class. So you should have submitted your assignment 4 and hopefully your tutorial 9, but if you didn't submit the tutorial, that's okay because I reopened all of them, and I'll probably keep them open until Monday morning. All right, so if anybody has a grade they're not completely satisfied with, but if there's room for improvement on your tutorials, and remember, if you do all 10, one of them, or I forget, one or two act as a bonus. I think one, but so yeah, that's basically where we stand. Um, Seeing how far we'll get today, it may be Wednesday is the last class, and we just kibosh this Friday one. It's always an awkward class because, who needs 3 lectures in the last week of, of school? I mean, I'm not going to put that material on an assignment, so I don't know. It's always, but if we have room, we'll or if we don't take up everything, we can definitely do the Friday class. It is possible we'll wrap it up on Wednesday. But any questions? Okay. Um, Last class we were going to talk about. No, it is a genuine bonus. Yeah, so I forget what they're worth, but approximately 1% each, so you can get like a 1% bump in your grade, right? So for those of you, and there's always a few every semester that send an email asking for bump me up to the next letter grade, the answer is, well, you are in control of it, all right? So um, I typically round grades up, but beyond that, you have to actually earn those extra marks. That's so yeah. Um, yeah, no, it's I don't know. I feel like everybody kind of. I remember being in university, and there's always one assignment I was just like, I did not, for whatever reason, didn't do my best on that assignment. Um, yeah, it's good to have an opportunity to make up some grades. All right, last class we were talking about exceptions, and we had gotten to the GDB. So we're just going to do a short demo of what you can do. Again, I think this belongs in the beginning of the semester. I'm going to move it, but better late than never, I suppose. So where we left off was we had compiled all of our object files using this -G flag, right? And what that does effectively is it puts a bunch of debug information in there. Uh, for the most part, it's your source code, right? So that as we walk through, it also, when you compile, it compiles, there's an optimized version, right? So your compiler can, depending on the stuff you write, can say, well, there's no point in doing this when I can do this exact same thing and it's much faster. And functionally makes no difference in your code. So there's a bunch of optimizations, but those get turned off with this flag, right? Because you really want to walk through your code explicitly and see what's happening. Um, so yeah, let's, now I'm not great at GDB. And yeah, we can see here, this is an old assignment. We're going to do our assignment. But the object file compiled without the -G flag, and we have, 12,000 bytes. With the -G flag, we have 114,000. So it's significantly bigger, but it allows us to walk through. And although we are going to do, the command line GDB, which is kind of, very, very old school and not quite as polished and experienced. There's a lot of, say, front ends on an IDE for this GDB debugger or other debuggers. And those are actually really nice, right? And they'll do basically the same thing, but they'll look a lot better doing it. All right, so we are in our old assignment 3. Everything has been compiled with this -G flag. So I'm going to do, oh, yeah. is it A3, I believe. All right, so here we are. I'm going to do, I like to see, you can just print it out as necessary, but I like to actually see what code we're running. So this is the compiled assembly for this. There is my source, but I want just the source. Register value is unavailable. Yeah, again, I'm not a huge expert. So how do we get those register values up there? I'm not sure, but that's a little beyond the scope of what we're doing. All right, so the first thing we want to do is, well, we can just run this code and it'll run, right? So I can print my stations and print my researchers and record a sighting and do all those things. I'm just going to exit though for now because we didn't set a breakpoint. All right, and now things get a little messed up, so we're going to refresh. Again, this is slightly unpolished, so you'll see that the what we're looking at sometimes gets a little jumbled based on the stuff that's coming out here. But let's set a breakpoint. So I'm going to say break line 5. All right, so there we go. And what this is going to do is it's going to stop running right there and allow me to proceed one step at a time. All right, so here we are. And now there's going to be two main commands that I might want to use. One is step and one is next. And let's see if we have, so we have layout next. Yeah. And it just gave us a view into the main.o, but we could actually look at other files and set breakpoints in those as well using the file command. Now there was, when I was playing with it earlier, there's some weird thing where I couldn't quite return to where I wanted to be. And then I figured it out and then I forgot how I did it. So we may or may not try and do that. All right, so we have breaks. If we want to set a breakpoint, we use break 5 or B5. That'll set a breakpoint in line 5. We can find info about the breaks and we can delete some breakpoint if we like. Now to walk through the code, we want to do next or end. That will give us the next visible line. Right, so we're looking at main. If I go next or end, I'm going to just jump over launch and into return. But I don't actually want to jump over this launch. I want to step into it. So I'm going to use the step or S. So yeah, let's step. All right, there we are in our launch function. And well, I can continue to step or next. It doesn't matter. Let's try next. All right, so that's initialize that vector. If I had pressed step there, we would have jumped into some vector code, which would have been sort of difficult to understand. Yeah. Next. Init. Well, let's see what init does. So I'm going to step into init. All right. So we can see that our control has a conservation object, and we can do something like print conservation. And well, it doesn't give us much, but it does tell us the, basically I have two vectors, one of researchers and one of stations for my member variables, and that's what it's showing us here. Currently, they have length 0 and capacity 0 because I have not initialized them yet. But once we start initializing them, they'll hold some values for us. All right, so next. Let's refresh because it's getting kind of weird here. Next, I don't really want to step into here. If I step into here, I'm going to land in these rand functions. Although I could step into the location constructor. Yeah, let's step into here. Yeah, so I am in, I believe, the rand. So if I want to get out of this function, I'm going to type finish. And then let's step in again, and I go into a second call to rand, and then step in again, and there we go. So now I'm in my location constructor. All right, so I can step through. I can skip over the stuff that I want and get right to the stuff that I'm interested in, or skip over the stuff I don't want. And so here I have, well, I have some variables I can take a look at. So x, well, that is my parameter x, and you can see it has a value of 86. And if I print this x, I have a value of negative 8,960. So my member variable x has not been initialized yet. So if I just go to the next step, and then I print this, we can see that it's been initialized to 86. All right, so that's kind of cool. I can step through and find the variables that perhaps have gotten corrupted and see exactly where. I can also do stuff like, so I have a get distance function here that you might notice. So I can say something like print this. Well, I guess I need to pass in a location variable. Let's just call print. This print. So yeah, this prints out, this gives me the output of that print call to print, right? So I can see my actual location being printed out. I can make sure that all the variables are there that I want. We can see longitude has not been initialized yet, but let's go to next. And then there we go. So then next, that takes us back here. Let's refresh. All right, so next. Now I can do stuff like print conser, what is it called? Yeah, print. And then I can say print conservation dot stations. And that gives me that vector. And I can say print conservation dot stations at location 0. And it gives me a memory address because that's a pointer. However, well, let's call print on this thing. And there we go. That's my station printed out. So yeah, I can walk through the code. I can look at all variables that are in my scope. This is just the very bare minimum that you can do with it. There's a lot more stuff you can do. You can see what functions have been are still currently on the function call stack. You can, well, I don't know, probably a bunch more stuff that I don't even know. As mentioned, I'm not really an expert on this stuff. I really like the idea of it. For the size of programs that we write in this class, I prefer just print statements because they are lightweight, they're easy to insert. You don't need all of this. I feel like this is a heavyweight sort of debugging scenario, right? And in particular, if you're using a lot of other libraries and things like that, then this can be very, very useful. But for our simple use case, I don't find this to be any faster, probably a lot slower than using print statements. Anyway, questions? It is still kind of very cool, I think. Is there anything else we want to see? Yeah, so you can grab any variable that you want. Here is the simplest set of instructions that you can, that give you the most basic access. There's a lot more complicated stuff you can do, but As mentioned, I'm not really an expert. All right. So that will take us into files and streams. I think I'm done with the woo claps. I was looking at it this morning. I was trying to think of some new ones, but I don't know, man. I'm just tired. Tired, and I have other stuff I have to do, like make exams. So I think we're done with the woo claps, but let's look at files and streams. There's some cool stuff here. This is a short little thing. So I think we'll have this and probably functions as parameters, and that will take us through today, perhaps. But streams, what are streams in general? Well, it's a sequence of bytes, right? So, and you can generally, I mean, a stream can be anything. It doesn't have to be data going from a source to a sink. It can be sitting there in memory, but typically we think of it as flowing from somewhere to somewhere, perhaps buffered. Yeah, some examples of source and sink. So when I type on my keyboard, that goes into memory and then comes up on the console. And files obviously are a source and a sink, and printers are a sink. Network adapters are both. So the input-output stream library has these two, I guess, parents, right? But the input stream, we have an important object is our cin, that is our standard input. The output stream are important objects that, well, we've focused on cout, but there's also cerr. So the error output, which also goes to the console, but if you're trying to distinguish between what's an error message and what's an output, you can definitely do that. You can pipe them into different places. You can pipe this into a log, but you also have clog. Streams maintain error bits, right? Good, bad, fail bits. And then we have a bunch of member functions to test these bits. And so, well, things can go wrong with streams, basically because they are typed. That would be the main type of error, is that I give it the wrong type of data, and it becomes very unhappy with me. Other things we could do with streams: overload the not operator and cast to void operator. So what these things say essentially is that I can just test my streams as I would a Boolean expression, right? So I can do something like this: if cin, and that basically is going to say, well, if this thing is still good, then go ahead and execute this block. If one of my error bits has been flipped, then don't. And in addition to this, I can add this, right? So just testing cin by itself is this cast to void operator. Again, it's a fancy way of saying I can treat this like a Boolean expression, and then I overload this, which also gives me back a Boolean expression, but now it's the opposite, right? So now I'm saying, if something's bad on my cin, please execute this block. All right, so let's see. Oh, I have to get out of here. Just give me a second. We are in 20, yeah. All right. Okay, so we are going to, well, show you that cast to void, and so here we are going to, basically we have a string, two strings, and an int. And we're going to ask the user to input two strings and an int in that order. And so we're just going to set up a while loop, and that's going to keep reading and keep writing basically forever until we trip an error bit, right? So if, recall that we have, well, typically this stream extraction operator is set up with chaining. So that this, of course, I execute this, it returns cin again, and then I execute cin with this, and then I execute cin with this. And then at the end, it returns cin again, and then tests to see if any of the error bits have been flipped. Okay, so and then down here, we're going to say, well, is this still good? Because what we're going to do at some point is to exit this while loop, we're going to give it some bad data. And essentially, the only way we can do it is I'm going to give it a character where it expects a number. All right. Nope, wrong one. I forgot to compile. Okay, so enter string number AB3, and then it says you said AB3, AB4, you AB4, ABC, something went wrong. Okay, so it basically is going to loop forever. Once I give it some bad input, right, it cannot read a character into an int, so it flips this good bit, and then I can test it and say, is this still good? And you'll notice that this line did not execute. And in fact, the way it is written, it will never execute because it's always going to be bad in order to exit this. So yeah, something was wrong here. But yeah, that's just, that is the cast to void operator and the good bit. Any questions? All right, well, what do we have to do? See, the problem here is that if I tried to do something like this, okay, so now AB3 and it works, but ABC of course does not work. And also it skips this line, right? So once I flip this bit, this becomes useless. It's just going to keep skipping over it because every time it tries to use it, it checks the error bits, and the error bits say, no, something's still wrong. So we're not allowed to use it until we actually clear A, B, C, and then all is well. Still skipped this, eh? Because still skipped it. I'm pretty sure. Well, I'm not exactly sure what happened, but I think let's make a string S3, read S3, and see if S3 picks up anything. A, B, C, all is well. So yeah, what happened was when I tried to read C into this, it failed, of course, but C is been left on the buffer. Not only C, but also the new line after C. And so it skips, it clears this, and then it executes this, which reads in the C and the new line, and then prints it out. And then we get down here, and it says, when we test to see if our thing is good, it says all is well. That is to say, oh my goodness, input buffers, I swear to God, if I have errors in my code, it is from misusing input buffers. They always like leave little characters, and depending on which way you call it, maybe the new line is still there, and sometimes it's not. And if you're on Windows, you maybe have a carriage return as well. And oh my goodness gracious, the number of ways you can mess up an input buffer. But yeah, so when you're using them, be careful. But that's a little intro, I suppose. Questions? Okay. Oh yeah, sorry, we do have more to go here. End of file. So that just takes the cast to void operator. But maybe we want, well, especially if we're reading from to and from files, we might be looking for this little end of file marker. And but we can simulate that from the command line, right? So If I'm reading from the standard input and I hit Control D, that will be the end of file. And so I am going to keep reading in from the user a string and keep printing it out until the user indicates that there's an end of file. All right. So yeah, every time I hit enter, it flushes the buffer and executes another while loop there. I hit Control D and I get the end of file encountered, while loop exited. Of course, I have flipped this bit now, right? So let's see. I can't remember if the end of file renders that inoperable, if we do have to clear it. No, it still works. All right. Oh no, I'm still in there. End of file encountered, still end of file, all done. All right. So yeah, it's funny. It didn't catch the end of file until yeah. Well, I don't know. I typed in some characters and then I hit end of file and it returned, but it didn't exit. So just be careful. I don't know. Test it out, right? Test these things out very well before you use them. Again, because it's going to depend on what compiler you're using and what version of C++, et cetera, how exactly these things are implemented. But yeah, so Control D, end of file, and if I'm reading, you know, if I'm reading a file, actually, then this would be very handy. Yeah, okay. Questions? All right. Well, now that we've, oh yeah, now there's a couple more. Test get. So let's say I don't really like this stream extraction operator because the input buffer is a real mess, right? It can leave stuff on there that I don't expect, and then next time I go, or maybe a flag gets tripped, or, well, here I'm just going to say, well, I can get really fine-grained control over how I process my buffer just using the get. It's going to get one character at a time, and then I can decide what to do with that character, whether I can convert it to an integer or, you know, if I get a bunch of them together and they look like a float, I can convert to a float. Right? So it's a lot more work, but I do get that fine-grained control. And so what we're going to do is we're going to construct a string, one character at a time, until I hit the new line, and then I'll output that string. Yeah. So it processed my string one character at a time, but of course the the buffer doesn't get flushed until I hit new line. So once I hit new line, it did all of them at once, and it processed spaces, characters. I could have added some numbers, right? So 3.4F. So yeah, so then it's just basically a character buffer at that point, and then you can process it after. Questions? No. All right. Finally, there's a get line, which we will let's enable that. Sort of like get, but now I'm going to get a bunch of stuff at once. Again, you should kind of be careful, right? Because it can do strange things. So I'm just going to have a character, an array of characters. And I'm going to call getLine on my cin object. And so it's going to read basically up to max buffer 80 characters into this string, and then print it out. All right, so it's going to be some arbitrary length, and then it's just going to grab everything up to 80 and print it out. What happens if I go above 80? Well, you got to be careful. So now it's going to get up to 5 elements. But my buffer still has size 80, so memory-wise, I'm still okay. But hi there, how are you? And it just takes the first 5 characters. Well, it actually takes 4 characters and then plugs a little end, what do you call that? The terminator character, the null, right? The C terminator, string terminator, basically. All right. So you got to be careful though, of course, because it is an input buffer. The rest of that stuff is still sitting there, ready to ruin your life if you're not careful to flush the buffer. And I'm not going to do it here, but if I made this buffer 5 and then I tried to read in 10 things, it's going to let you. Actually, maybe let's try it. Probably we'll get a seg fault. Stack smashing. All right, well, so but at least it crashed, right? So apparently we ran over into our stack with that buffer. So yeah, these are not safe to use. You still have to be very careful. You can use custom terminator characters. So it's still going to wait for the new line, right? So for me to hit enter before it flushes the buffer, but so every time I hit new line, it processes some. But it's going to end at the star character like I asked it to. Now, of course, good is still sitting on the input buffer, so you got to be careful. Good along with the new line, which means you know, your next call to cin is just gonna pass right through there. Yeah, I think that's the same example below. Good question. All right. So different ways you can read from your standard input. All right. So using the get and the get line uses it's unformatted data, right? So basically, it's taken in bytes. It's going to read them as chars, but right, that's sort of irrelevant. I could save an object, let's say in binary. Now it's a little bit tricky because a lot of objects have a lot of pointers to a lot of places, so it's not really straightforward, but technically you could do that. And then I can still read it in, you know, using a bunch of chars, which are really just 8-bit integers at the end of the day. They're just information. But when we use this stream extraction operator, it's because we expect a certain type of data, right? So, and then it's going to format it for us, right? So we're going to read in some characters that look like ints, and it's going to change those into an int for us. But of course, if we give it bad data, it's going to flip those error bits. All right, so that brings us to files. So a stream kept in persistent storage, right? So as mentioned, for a stream to exist, it just needs to be a sequence of bytes. It doesn't have to be flowing anywhere necessarily. So files are streams that are not going to be deleted when I turn the power off. That's what this non-volatile means. So they are an array of bytes terminated by an end of file marker. And in C++, of course, we can represent files as objects. here is this is the UML of the inheritance hierarchy of these input and output streams, which kind of shows you, right? Inheritance is kind of weird, right? Because now I have, instead of my input stream and output, or input file stream and output file stream being inheriting from file stream, they're inheriting from input and output stream. So because these are trees, you kind of have to make these arbitrary decisions about, oh, what is the best way to structure your inheritance hierarchy, which is one of the, and I'm not bashing object-oriented programming or inheritance, it's great, but this is one of the weaknesses of it, is that sometimes it's like, well, should I structure it this way or that way? And it can have unforeseen consequences, but it's hard to figure out in the moment. And once you figure it out, it's there forever. But in this case, we have an input file stream derived from input stream, output file stream derived from output stream. Both maintain a file buffer. There's a destructor that will close the file for us. Again, these are streams. We can use these negation and the cast avoid operators, so we can just test them as if they were a Boolean expression. All right, so let's take a look at some basic file management. So we have our student class. Let's get rid of this for now. That's a surprise for later. Well, actually, let's do this. It's always something I forget to rewind, but there we go. We have a student and we've overloaded the stream insertion operator. So we can send things, we could send this student to a stream. Typically that's, the cout, but here we're going to send it to a file, students.txt, right? It's an output file stream. And it's as simple as declaring it like this with a file name. We can test to see if this file had any problems when we were trying to open it. And then we're going to say, well, our students have a student number, name, major, and GPA. And so we're going to make some students. We're going to take this information in from the user and construct a new student using these variables. Okay, well, we can do something like this. What is it? Number, name, major program, and GPA. No, it's not called number, it's called num. Okay, and then we can say, let's make a new student stu. And then we're just going to send stu to the file. Out file, stu, and an end line. All right, so that is the nice thing about these overloading these stream insertion and extraction operators is that, well, it's not just cout I can use it with, it's files. Perhaps I have something that connects across the internet that I can send these things to. And then when we're done, we can call close. If in this case, we've statically allocated this object, which means that, well, as soon as I call the destructor, it's going to close the file. And the destructor is going to get called once I exit here. So, but anyway, let's see this in action. Enter student number, name, 1A, major, CS, GPA, 12.0. 2B, math, 3C, Now, this is going to keep going basically until I flip one of these bad bits, right? So I wonder for Control D. Control D, that worked also. Okay, now if I check my student.text, we can see that I've actually taken that input, I've made a student object, I've used the stream insertion operator, and printed these students to a file. And it gave me the nice formatting that I would get if I was printing it to the console. Yeah, questions? All right. And yeah, I guess I could also do something like this and show both of them at once. But all right, so we might come back to that, but let's go to the stream. So now maybe I want to read from this file. Well, first of all, actually the way this printed. All right, well, I'm just going to take these new lines out because they are going to be annoying. But let's say now that I want to read these students from a file. Well, I can do something like this. So again, I have all of these variables that I can put information in. I also have this garbage, which we'll get to in a minute. But basically, I want to read. So my input file, and this is basically the same as if I was reading from the standard input, right? No different. I'm going to read it in exactly the same. Well, there is one slight difference, right? Because this is not just raw student data. I also have a little bit of formatting here. So this white space is going to serve as a delimiter by default, right? So it's going to read well, the first thing it's going to read is this student. Well, this actually I don't want, right? That's not actually information that I care about for constructing my student. I want the next thing. This is an int. Or is it? Maybe it's a string. Num is a string. All right. So I want to read garbage. That's going to read that student. Then I want to read my number, num. And then I want to read the name. And then what else? Oops. Major. And then after major, well, again, I have this kind of pointless string. If I'm trying to construct a student object, this is not data I'm interested in. So I'm going to get rid of that as well. Major, and then garbage, and then GPA. Okay, so let's make student stu. And push stu onto this vector of students. So studvec. Okay. And then after we're done all that, we're going to print out the students by, using our iterator and copying it to the output stream, which again is going to call on that the student, this thing here. All right. P2 in, so it reads all the students from the file, pushes them onto a vector, and then prints out that vector. And we do have to be careful. It's nice that we get that automatic formatting, but of course, when we read it, we have to throw away these formatting. This is not any useful information for my student objects, but all right. Just thinking, I asked you to do this on assignment 4, right? Yeah, anyway, there you go. You can do it to and from a file as well. Questions? Okay. All right, well, this is actually, why am I doing this when I can just overload the stream extraction operator, and then, well, then it becomes real easy. But so now I have some arbitrary input stream, and I basically want to do this same thing, right? Assuming that I'm going to make an assumption here, and my assumption is that the data that I'm reading has this formatting, right? So I'm assuming that I use the stream insertion operator to create this data, and now I'm going to use the stream extraction operator to read it. Let's make a string garbage. But otherwise, I can read things in directly into my stew number. All right, so I pass in an input stream, I pass in a student object, and I just read, assuming that it is formatted the way above here, I just read everything directly into my member variables, right? And then I don't have to, well, then what happens here is I can do this. I can make it a student temp, let's call them. And then I can read into my temp student, and then I can push that temp student back onto my vector, and then print it out. And then this is quite simple, right? If I've written to the file using this, I can read from the file using that, and everything should work except for this. All right. All right, and there we go. So we read it in, but now we're using the stream extraction operator of the student class. All right, questions? Okay. I think that's basically it for files. Again, it was very short. There is, right, if I'm, say, writing to a file, I can use this put, which will put one character at a time, right? It's sort of the mirror image of get. There might be a put line. You have to look it up. But we can also flush, right? So typically these things flush, well, under very specific circumstances, you hit enter, or or it fills up, or you call for it explicitly. So sometimes you want to call for it explicitly. Yeah, so here are a bunch of flags. The good bit, right, we've tripped that by not putting in good data. The fail bit, some formatting error. I don't know. I would have to look up exactly what that means. The bad bit, some unrecoverable error. Something went really wrong. And the end of file bit. And clear resets all your flags. Yeah, the end. All right. That takes us to any questions on files in general? All right. So in your assignment 4, you didn't have to work with files, but it did use files, and I believe it used similar formatting. All right, so let's look at something we've seen a little bit with the standard template library is we passed around functions. So now we're going to go over them in greater detail. So some of this, it's a little bit of review, but not much. And then we'll talk about lambda functions and functors. So sort of getting into modern C++. So C++ is a strongly typed language, right? So that means all variables. When I use a variable, it has to match some type. Even if I use auto, there's always an explicit type associated with it. And functions are no different. So if I have a variable that contains a function, it has a specific type. So what is that type? Well, function signatures, which we recall, how the compiler discriminates between different functions. Well, if it can have the same name as long as it has different types of parameters or in different order. So that is part of our type, but not all of it, right? So actually the compiler does not care about return type, but we do need return type for a variable. So yeah, well, let's. All right, we'll get to you in a second. Okay, so here we have a little program. We have 3 basic math functions that operate on integers, and they basically all have the same signature, right? Now, signature is not really the right word here, but the same type. They return an int and they take 2 ints as parameters. The difference is what operation they do. And then we have a little program that, you know, takes some input and calls a different one based on the type, or based on the opcode that we give it. CT, I don't even know. I think it might be 20. Oh, right. For whatever reason, I did not put a makefile in here. Okay, 2 integers, 4 and 5. Let's add them together. 4 plus 5 equals 9. 3 and 4, let's subtract, equals -1. Okay, great. But of course, I have this big, well, actually, this is, no matter what, I basically I probably need this switch statement. But let's say that instead of outputting these, hard coding these directly, I want to make a variable that will hold them. And so let's make a variable. It has a return type of int. I'm going to call it func. And then it takes 2 ints as arguments. And then I would try to assign it add, let's say. All right, well, first of all, I got the right idea. Now, for functions, the variable name goes here, which is going to be kind of weird, right? Because this sort of, it's not so bad here, but once you start passing functions to functions, the fact that this is nested in between my return type and my parameters is going to look a little weird. We're not really going to get deep into that, but that is sort of a major complaint of this style. But what's more, the compiler actually doesn't know what this is, right? Syntactically, it's ambiguous. It thinks I'm declaring a function explicitly, not a function variable. So I'm going to tell it, well, I want a function pointer, actually. But that still doesn't help because this can be read as returning an int pointer. So I'm going to I'm gonna do this. Oh no, sorry, this. There we go. So this is the format for how you declare a variable to a pointer to a function. And then I can do this. If I call to add, it's going to go to add, but it's going to go through this variable. Oh, yes. So 4 and 5, and if I do addition, I get 9, so still the same thing. All right, so that's just, again, C++, it's an old language. There's, I think, is it Go? Go uses something that looks a little more like a traditional variable, right? Like type followed by name. I don't remember all the details exactly, but this is a little weird. But it does work. I can assign it any of these functions that have the same type. Now add is going to call my func, which will actually do a multiply, so I'll get a 12 there. But yeah, so now I have a variable that can point to any function that has this specific, let's call it type. I'm going to say signature a lot, but that's actually not correct, but hopefully you get the idea. Questions? Okay. All right, so that's very simple, just a type. Well, let's pass it as a parameter to other functions. So we've seen this happen before, but there's a couple of little caveats here. So again, we have add, multiply, subtract. Now we also have this invoke. We got a couple different invokes here. And in fact, before we confuse the issue, let's stick with a single invoke. So what we're going to do is actually, based on what I asked for, we're going to invoke one of these functions and pass add, multiply, or subtract as a function parameter. Okay, and here the signature is exactly the same as if I declared a variable. Func is the name. This is all stuff we don't need currently. All right. 4 and 5, and let's do multiplication. And so 4 times 5 is 20. So we successfully called invoke. Mainly for stuff like this, where I'm passing in a function, right? So this is, I mean, we saw a bunch of examples of this in the algorithms library. So I have some data that I maybe want to sort at some point, or find the minimum, which means that I need some way to compare them. And you can overload the less than operator, which works, but then if I want to compare them using a different function, well then I need to make a function and pass it in explicitly. So in this case, right, invoke basically doesn't do anything. It's just an extra step that we put in arbitrarily so we can demonstrate this. But for sorting, I would need to figure out how to sort. Do I sort alphabetical order? Do I sort by student number? And so I can have a bunch of different functions that I can pass in that all have the same signature, but sort things a little bit differently. So yeah, other questions? Okay, well, this is one way to do it. It's kind of limited actually, as we're going to see later, but let's first look at some other invoke functions. I'm going to call this invoke2. And I'm trying to remember how to do this. What is it? So I'm going to use from this functional library. I can't. It's oh, here we go. I'm gonna have to look it up. I can't remember the format. I believe what is it? Something like this. That can't be right. Hmm. All right. Let me look it up. Yeah, all right. So there it is. Kind of had the right idea. I just forgot this, I believe, right? No, there's no. There we go. Okay. And now I can, well, now I get, I mean, this is not much simpler, but at least I get the type followed by my variable name now, which kind of looks a little bit better. There's other advantages to using this as well, as we'll see when we get to lambdas, right? This accepts a lambda, whereas this does not. But yeah, let's see func2 in, or invoke2 in action. Four and five, let's subtract them. And then the result of my operation is -1. Okay, so that's two ways to do it. And while they don't appear to be different, this is going to be a lot more flexible, as we'll see. This only takes one thing, but there are kind of other ways that we can represent a function that aren't truly functions, and then this won't accept them while this will. But for now, we'll come back to that. But any questions? Okay. The third way to do this, invoke 3. Well, let's say that I am really lazy, but I do realize that, well, if I do something like this, no, I don't want to call it that. Plus F. Well, even though this is not the traditional format, right? Because up here, the func is right down in the middle, but the compiler is going to be smart about this. It's going to see if it can match this pattern. And so when I call this with a function, it's going to replace f with that function and then do all the hard work for me. Then I don't have to worry about the exact syntax of my function. All I have to do is call it 5 and 6, 5 and 56. Let's multiply, and I get 280. So yeah, invoke 3 works just by taking advantage of the template and making the compiler do all the work in figuring out the exact type and if it compiles and whatever else it needs to figure out. This is a lot more flexible, right? But yeah, questions? I mean, technically, if I wanted to make a function that multiply two floats, this will work for that as well. Well, not quite as written, but I can, of course, well, now I can use arbitrary types, and as long as this function that I pass in matches the types of my parameters, this will still work. Okay. All right. Good, so that is 3 ways to pass a function as a parameter. This is the old school way. These other ways have advantages, as we will find out. Yeah, so we can declare the type directly, we can use a template and let the compiler do the work, or we can use a functional library. Those are the 3 main ways. So that brings us to, well, what does all this passing of functions let us do? Well, typically we use that, well, we can use that just about anywhere, but that is a functional, not functional, sorry. Is it functional program? Yeah, functional programming style, right? Where we pass around functions as first-class citizens. So yeah, if your language supports functions as first-class citizens, you get to do things like assign them to variables like values, which we can do. We can pass them as parameters like values, which we can do. Constructed from expressions like values. I believe modern C++ does actually let you do this one, but I have not tried it. I actually have no idea. I just saw some random thing somewhere on the internet that mentioned that you can do functional programming in C++. So I'm assuming that's available at some point, just not to, maybe not for our version. So what that means is that, like in Haskell, I can take 2 existing functions and I can combine them and make this third super function, right? So basically I run H on input X and then that becomes input to G. But I can compose that in Haskell without actually calling these functions and just have it sitting in a variable ready to go, which in C++, or at least I might have to update this at some point, but it does not do that I know of. It does have lambdas, however, which are anonymous functions, which are kind of useful. So no name, just the signature and implementation. The signature must match to be used in a variable or as a parameter, of course. It's a strongly typed language. I can write it within another function to be executed later. It's all fun stuff we can do with lambdas. Okay, so we have our, oh yeah, type name. I guess I didn't need to. We have our functions, add, multiply, subtract. We have our invoke 1, invoke 2, invoke 4 in this case, but yeah. Also, you may notice I did not put the star here. This is one of those places where C++ does not care so much about the exact syntax. You can do all kinds of wacky stuff here. Maybe not that. But certainly we don't need this. Typically we would need. Typically we would need to do this. But it does. The compiler doesn't actually care when we're passing it as a parameter if we do exactly that. So anyway. Yeah, let's back it up here. So what we're going to do is we're going to write, I want to call this invoke on X and Y. I don't really care about the operand. I'm going to just do whatever I want. So the syntax of a lambda, this is called the what's it called? Capture clause. All right, so that's how we begin a lambda. And then we are going to have Parameter list, optional trailing return type, but the compiler will just infer it if we do not give it a type, right? So I can use the arrow to say this will return an int, but also I can just return an int. You could see, oh yeah, okay. So there we have a lambda anonymous function. Does something. It takes x and y as parameters. It's not being called right now, but I will call it when I call this invoke one. Hmm. Plenty. And that actually works now, huh? Yeah. All right. Well, that's why you always test things, because the previous version of the compiler did not work here. But this does. So this accepts a lambda. That's interesting. Huh. Well, that's unexpected, but there you go. So you can use this. Once upon a time, depending on the version of C++, this did not accept lambdas. You would have had to call invoke2, but lo and behold, I could just pass it as a simple, oh no, you know what? Sorry. That's right. It does accept this so far. Later, we'll make some changes where it doesn't accept it. Let's try invoke2. Again, I'm going to pass it a lambda. Add them together. Well, it's always calling multiplication because that's what I passed it. But yeah, that also works. And invoke4, which does the template compiler trick. And then the result is 20. Okay, so that works for all of them. So far, questions? All right, so how can we break this? Geez, I should have reviewed this a little more. But let's say, well, there's something else that lambdas can kind of do that may or may not be cool, but they can capture variables from the surrounding context, right? So what does that mean? That means, well, I'm going to grab W here. Oh, we can see immediately it does not like what we did. And I can include W in this expression, right? So this is captured here by value in this case. It does not, my invoke function does not like it. So there is no way to convert this into a lambda with a captured variable. But luckily, the functional library is here to save the day. So this can actually be used with a lambda. And so now everything I do is going to be multiplied by 10. 5 and 6, multiplication. The result is, of course, 30 times 10, which is 300. All right. So this is passed by value. So I could do something, let's say, no, it doesn't like that, huh? Non-mutable lambda. Oh yeah, there's a mutable clause. All right, forget it. So we'll keep it simple. So yes, I can pass that in. I can also pass it in by reference if I like. So for large objects, this might be preferred, so I don't have to make a copy, but this should work exactly the same. 4 and 4. And 4 times 4 is 16, times 10 is 160. And yeah, let's test it out with invoke 4, where we make the compiler do all the work by just saying, well, it's a templated type, you figure it out. There we go. 2,240 using this. All right, so that's it. That's, a lot of languages have these anonymous functions, and this is C++'s version with an additional capture clause. And yeah, questions? Okay, we're almost done, but so yeah, the anatomy of a lambda, we have the capture clause goes first, followed by the parameter list, followed by a mutable specification, which we're going to skip. As we saw, that would allow us to change variables. An exception specification, we could throw exceptions from there. Trailing return type, which is optional. I don't think I showed you, but I could just leave that off, right? I don't have to put that on there. It'll figure it out, but if you want good readable code, that's probably a good idea to leave it in there. And then the body where we have some stuff. So I showed you how to capture, surrounding context. In this case, W and Z would have been passed by value. I could have passed them both by reference. Now I have to be careful. I have not tested this because it's sort of convoluted, but technically I can send this lambda away somewhere, captured W and Z by reference, and have this function popped off the function call stack and W and Z destroyed before I call this lambda, and I'm guessing that would cause problems. But I haven't actually tested it. We can ask for the entire surrounding context to be captured. So if I put equals, everything gets captured by value. Or I put this little ampersand and everything gets captured by reference. And we can be selective about it, right? I can ask for everything by value except for W by reference, and or everything by reference and W by value. All right, well, we're not going to finish this today. I will probably stop there, but there is one more way to sort of pass a function, and it's kind of useful, but I'm going to basically overload this operator. And so I'm going to have an object that basically behaves like a function. So syntactically, right, because especially with things like templates, as long as it compiles, it works. So if it's a class instead of a function, that doesn't actually matter to the compiler. The compiler is just making sure it compiles. So yeah, but we'll leave that for next class. And then that takes us to the end of that. And then next class, I don't know, I'll let you guys know. I mean, there's one more lecture I could teach, but I could probably teach that and do a review at the same time. So maybe Friday's class is canceled, but I'll let you guys know. So that's it for today. If you have, again, if you want your, the best mark possible, all the tutorials are reopened. So yeah, I'll see you guys on Wednesday.